do Boss of the Sock, which I think you will see is much more fun. You go to Projects. Down here is Boss of the Sock. So you're going to connect to one of my cloud servers. I have 2 of them. I'll just turn on the first one. Now you need a name and password. The username is student1 and the password is student1. No security, and it tells you that on this page. The only reason I did that is because if you put up a Splunk server with no password, these automated bots hack it and trash it. So I put just a simple username and password in front of it, and that's enough to stop the automated bots. So, and it warned me there, the time on the server is strangely wrong. Like I said, my server thinks it's 2018 or something, so you can look at really old data. So now you go to Search and Reporting. This is running on Linux, so it moves. You saw how that Windows thing was crawling, even with just 3 little files with only a few thousand records. This has 1 million records, but it's running on Linux. So there you are, 1 million events 8 years ago. So if you go to the base search page, you can go to Data Summary here. And this is what you do to see what you got. And what happened is Splunk took some of their workers and they told them to set up a fake company. They got about 10 Amazon servers. They made a whole fake company, and then they attacked it with a whole bunch of attack tools. And they logged all the logs and saved that data, and they made a contest where you could practice finding it. And I played the contest and I won, and I said, this is wonderful, and I'm going to put it in my classes. So here's
each one of these is a database file.
Yeah, it's a category of data. Yeah, it's probably multiple files, but yeah. Okay. So here's the host name that the company assigned, like Web 8105 Desk, whatever that means. Here's the source, and notice there's more sources than hosts. Here's Suricata, and here's something looks like a Windows website, but the most useful thing is source types for us. Okay. The source type shows you what type of data exists. So these are Windows event logs. This is Windows registry. Here is Windows Sysmon logs. Sysmon is wonderful. Sysmon is a Microsynavich product. It's a sysinternals tool that you add to Windows servers, and it makes much better log files. If you've looked at Windows event logs, they are really, really painful. If you open a folder and open a notepad file, there are 100 events in the Windows event log. It is ridiculously detailed. Every little action is 10 or 20 events. So searching through that to find out what happened is very frustrating. Sysmon is wonderful. It has only like 10 events, and they're easily meaningful, like a file opened, a process created, a process terminated, a network connection opened, a registry key written, and it just gives you everything you need. Like it tells the file was opened, it gives you the username, it gives you the MD5 hash of the file, it gives you all the information you need without a bunch of garbage. So Sysmon is an optional thing you put on Windows machines, and it's a very good idea to put it on. Yeah.
Are these source types generic where we could Google them and get a basic understanding of what they are?
Yes.
So it's not necessary for us to rail off like you're capable of remembering.
And you'll learn. That's what I said. The real learning in this class is learning Windows internals.
Sure.
Learning what the logs are like. Splunk is very simple. It's the logs that are complicated. And like I said, the Windows logs are too complicated. The Sysmon logs are easy to understand.
So if you, and I've done this for some troubleshooting before.
Yeah.
So, like if you're learning Python or something. But basically, if you're looking at a log event that you just don't understand, stick a portion of it or all of it into Google and see what they come up with.
Yeah, I used to teach Windows tech support, and this is what you do. There's an event ID field, which is just a number, and you Google the event ID, and you will find people will tell you what it is and what it means and what to do about it. The logs themselves are pretty impenetrable, but if you Google it, all the server administrators in the world have made blogs listing when you get this event, that means you have this. You can just ignore it frequently, or they'll tell you what's wrong and here's the adjustment to get rid of it. Like I say, if you look at the Windows logs, you will find that your Windows machine has 100 things wrong with it. They all do. It's amazing how complicated Windows is. Getting all the log and getting all the errors in Windows fixed is like a week of work.
Why is it such a market dominator? Is it just because it got there first?
It is the all-purpose tool. Whatever you're doing, Windows has it. It has 1,000 features, of which you only need 20. That's why if you make a server and you're expert, you use Linux and you get just what you want, and it's much faster. But Windows has everything. It has a GUI, it has email, it has all this stuff built in. So I mean, it's like a luxury product that has every feature. You don't need all its features. So it's big, expensive, and slow, but it's easier to use. And normally, humans are the most expensive part of your company. So giving them a tool that's easier to use is more important than efficiently using your hardware. So that's why end users prefer to have Windows or a Mac with all these features. But servers like to run Linux, where you trim it down and run just the one thing I need to get the most value out of the hardware. So, they both have their place. Anyway, so this is the Sysmon. Here's FortiGate, a FortiGate firewall, passing events up. Here's a Windows web server, IIS. Here's Nessus scan from some kind of security scanner. And here's the stream data. The stream data is monitoring the network, looking for DHCP, DNS, HTTP, and other protocols. These are summaries of all the network traffic it saw using those protocols. And here's Suricata, which is an intrusion detection system that analyzes network traffic like an antivirus engine for known attack patterns. And this stores the information that Suricata forwarded. So all this has been forwarded to my Splunk server, and we're searching through the data. And you see here's the number of log entries in each of these categories. So this gives you a summary of the kind of data we can see. So let's find some attack traffic. We're going to start let's start with index equal bots v1. There's an index here. Let me zoom in on this. Okay, index. The name of this is bots v1, which is the name of this game, Boss of the Sock, they called it, and this was version 1. So you specify the index, which is a good practice, although in this case it's not necessary because there's only one index in use. Now if I search, it goes really fast and I get 0 events. The reason I get 0 events is because it only searched the last 24 hours, and my data is 8 years old. So there is nothing in the last 24 hours. So I want to search all time. Now the other problem is, remember, the time it takes is dependent on how many answers you have. Since I had 0 answers, it ran right away. If I get all 1 million answers, it'll take a long time. So if I want to do that, I'm going to sample it. I'm only going to look at 1 in 1,000 of the events to make it faster.
And is that actually going by the count of the data line? So
no, it's random.
0. Oh, it's random.
It's random. So it does not give you the same answer every time, which is pretty rude. But anyway, now I set it to all time. Okay, and now it only took a few seconds, and it gave me 985 because there really are 985,000 events. So I'm only seeing 1 in 1,000 of them, but now I get a general idea what kind of events are here. So here's the individual events. Some operation completed successfully. Here's looks like a web request with XML. Oh, this is Sysmon. This is some Sysmon event. So here's,
Sam,
yeah.
Quick question. When you go back up to the top, the index, you found that in the data summary, right?
Yeah, they told us
Okay,
that.
I
Yeah,
just missed
the company had to assign an index. That's
Right,
right.
yeah,
Yeah, that's right. You added that when you put in the data sources.
Right.
And so here, by the way, there's different ways to view this. This gives you one view. That's list. You can also go to raw, and then you just see it in its original format. And you can also go to table, which will put them in columns across here. Usually,
Can you pivot the table view at all? Is that possible?
yes, after you do a query, you can do all that stuff.
Okay.
Yeah. And so here, you can also expand it here. And that's why this way, you get a sort of summary of it. And if you want all the details, you click this, and now you see every field showed up here. So you can see all the information. So you can look at log entries one by one here. But of course, that is not a very good way to use Splunk. I mean, you could have done that without Splunk. So, I mean, it can do that, but that's not usually the most efficient way to get anything done. So what we're going to do now is look at HTTP data. So we're going to, this is what you do. Now, I could type this in, but I would have to spell it exactly correct. And you can learn and type them in, but that's not the fun way. The fun way is to use the GUI, so you don't have to figure out how to type and whether to use quotes and all that jazz. So what you do is you go back to the home page, search, and now you have a data summary. So you open your data summary, and remember here you can get the types of data that exist. So I can go to source types, and if I want to see the HTTP data, I just click this. And it will type that in for me. So now I get all the HTTP data.
And then you do the time adjustment again.
That's right. The time is wrong. Yep. So I got to go to all time. Now I'm doing no sampling, so there's going to be quite a few of these. This is all of them. I think
Theoretically, you're looking for a smaller slice of data because you're looking just for the stream type of HTTP.
that's right. So there's 1 million events, and I'm getting 23,000 of them. Those are the web events. And let's go back to here. So if you do that, you're going to find 252 events if you're looking at 1 in 100. I didn't filter, so I saw them all. 23,596. When you see the green check mark, it's found them all. And so it shows you a timeline, so you can see almost all the action happened on August 25th, 2016. And a little bit of action later, and nothing in between.
Sorry,
this was,
how is that graph stacked? Is that
it's
are
horizontal.
those individual
No.
vertical lines?
No, if this is 23,000 events on this one day, August 11th.
So if you were looking at this and it was representing events that went past that, that starting date would be whatever.
Right, and you can
then
drill
the end
in.
date is the end of the log file.
Yeah, and you can drill in. Like if I want to see what these are here, I can click that,
Oh, okay.
and it will zoom in to just that day. And then I can click it, and it'll zoom into just that hour. You can use this to graphically zoom into time.
So what do the vertical lines in the histogram mean? Is that just
The
the
total-
volume of traffic?
Yeah, number of events. Yeah, and so you can see it's now limited me to this time range here, 8:24 at noon to 8:25 at noon, or 12 at midnight. So I now looked at just one day, and if I click it again, it's double click it. I think it's going to zoom into like just 1 hour. Yep, from 9 to 10. So you can control the time that way too, to zoom into just a small interval of time. And now I'm only down to 842 events. So that's one way. And now I could research, like, want to know what this is. I could double click on that and zoom into just that event. And that's only 116 events in a small time period here between 9:36 and 9:37, 1 minute.
It looks like it says format timeline, so you can change.
Yeah.
You can change it to be like points on a graph rather than a histogram. If you want.
Yeah, I'm not sure what adjustments are there, but you can adjust it. Yep, very good. All right, so let me go back to all time here, which is going to be presets, all time. Okay, that should get me back to my 23,000 events. Okay, that's all the web traffic in the data. Now, what we're going to do is we're going to add the domain name of the company. And they based this on a Batman movie that was popular at the time. So the domain name for this company is I'mReallyNotBatman.com. Now this is all the web traffic that it picked up. But if I add this, then it's going to only take events that include that domain name. And those are going to be events to my web server. Nothing else would have that domain name in it. Yeah.
Would that also work with like an IP address or
Oh, yeah.
anything related that a system protocol would recognize?
Just like Google, if you just type a word here, it will just give you events that have that word anywhere.
So it works just like an index search engine.
Yeah. Now, if you do this, if you do field name
Specific
equals,
query
then
types.
it'll look just in that field.
Yeah.
And Splunk very much recommends doing this. This is much faster.
Right.
This searches through the whole event for that string.
Right.
I do it all the time because it's easier, but Splunk doesn't recommend it because it supposedly wastes more CPU time.
But if you knew exactly how to qualify that particular
Right, like host
query
name
type-
equals this or something.
Right, okay.
But this way, it's going to give me any record that has that string anywhere.
Will this also do like math processes and things like that?
Oh yeah, oh yeah, it does some and histogram and everything. So now I'm down to 22,000 events going to my web server, and I can look at them. So here, if you go down here, you'll see this is the result document moved. Here's the source. Here's a web request. If you know your HTTP, this is a web request. That's a web response still, I think. Someplace down here is going to be a web request. Let's try this.
I think you passed request.
Maybe I'll show as raw. Okay. Notice this. This is what I wanted to show you. This is an attack. It's doing a search. It went to this is the URL. It went to I'm Really Not Batman Joomla index component search, but the search word is this garbage, select 0 from select sleep. Now, if you've taken the hacking class down the hall, you'll recognize this is a command injection attack. They're trying to trick the server into executing these commands. This is not a normal search word that a human would look for, like the name of a product they're trying to buy. This is an attack, select from sleep. This is a command injection attack. So what you're seeing here is attack traffic, and that's what I wanted to show you. Most of the traffic is in fact attack traffic. And we want to understand, finding an event that's obviously malicious. Yeah, go ahead.
In terms of workflow, like let's
Yeah.
say you are actually doing this for work, are you
Yeah.
like maintaining a document separately
Yeah.
and using find functions and stuff and
Oh,
keeping your own list of like, okay, well this is what I found so far on these logs,
Oh,
and
yes.
this event thing. Is it best to do that in like a spreadsheet, or are there all kinds of different tools, and are you going to
Yeah.
touch on those workflow techniques?
No, but I should mention it, especially if you get in the competition team, you have to get good at keeping notes. It applies to all my projects too. Hands-on projects, especially the hacking projects, you should be keeping notes. You want to remember the things you found, and especially you want to remember what techniques worked. So I just use Notepad or a text editor. Other people use Microsoft OneNote. Some people even use cloud collaboration tools, whatever you like. But you should keep notes of what you're doing. It's very important because very often you try this, you try this, you try that, and you say, well, I've gone down a blind alley. I need to go back to what I had an hour ago and start from there. And you wish you had a note.
And if we were practically doing this for security investigation,
Yeah.
we would have to be careful about which tool we selected, where it lives, and how we use it.
Yes, when I did real forensics that went to court, you have to keep thorough notes of what you did because you have to explain what you did. And if you make a mistake, you write it down. You never lie or hide anything. You say, well, I made a mistake. If it matters. You know, if you tried something that didn't work and you tried something else, that's fine. But if you made a mistake, like you erased part of the data, you write it down and admit it. Lying is the worst thing you can do. You never cover anything up. So you have to write down in your ultimate report for forensic examination, you have to write down exactly what you did in enough detail that the other examiner can reproduce it.
Is there a workflow resource that you recommend, like Splunk workflow into YouTube?
No, there are people that write them. I know there's one for pen testing. There are people that make them. I never used them. I just used plain Notepad. But there are people that like to make those. There are pen testing things. Other people like them. I never got used to it.
So there isn't an industry sort of standard accepted, like, do these for your workflow, otherwise, you just made one.
Yeah, not that I know of, but a lot of companies make their own internal ones.
Right.
Like your incident response team will have a playbook where you develop these things. And then you train your staff. First you do this, then we do that. Yeah, and you'll see some examples if you take the incident response class, which I think we're not teaching this semester, but I do, and Mandiant has some recommendations. But yeah, that's an issue. And in the Capture the Flag contest, if you get in the subscriber competition team, we have a very good team. We beat Stanford once, we're very good. But one thing you have to learn is to keep good notes. You scan the network, you try this, you try that. You really have to keep notes of what you're doing. Because, you know, very often you decide to quit doing this and go back to what I was doing before, and you wish you had notes.
Are there automated tools to help you take notes?
Not as far as I know.
Really?
Yeah, and one issue is, of course, you've got to be on all different operating systems and stuff.
Right.
So that's why I prefer just plain text editors, because I always have them. Like if you want Microsoft OneNote, then what do you do when you don't have the internet? What do you do when you don't have Windows? You know, that's why I like just plain text files. But I'm old school. You know.
So do you set up an interval for yourself to add notes, or do you just know sort of like what are the touch points that really matter?
I record anything important. Like when I'm doing attacks, I record anything that worked, because I might want to do it again.
Sure.
Yeah. That's right. That's right. And so here, so you find some malicious traffic, and when you do, you'll now have several things. Yeah. What's up with you?
I don't think this is gonna work. I don't know.
It just took forever.
It's installed. No, it's already installed.
Oh, good.
I don't know
Then you
why.
just put in your username and password there. That's how it's asking you. So put in like student and password or something.
Okay.
I think it's working. Yeah. It's using a different interface. I think you're on the road. All right. So now that I've found some malicious traffic, I can answer a whole series of questions here. The first thing is, what was the scanner name? So I know this event is malicious. So if I look at the fields of that request, then I should be able to spot several interesting things here. If I go down here, okay, here's some document moved. Here's some kind of response. I'm having no luck finding the actual raw request. Search phrase. I want to see the HTTP request, and somehow it's not showing up. Let me see if I can figure out why. Let's go to list, and
Why wouldn't you just use a find function and search for a keyword?
well, I could, but I think what's happening is somebody is hiding some of the data here, and there's some way to turn it back on. Over here, here's data fields. HTTP user agent is one thing to look at. Let's try. Now, why don't I see HTTP user agent in this event? This is what's troubling me.
Sam, can I ask you a question?
Yeah.
What does the hashtag and the A signify between the different links listed on the left there? You have hashtag.
Oh, I don't know. That's a good question. I think I forget. Yeah. But anyway, I'll just go on to another one. I should be able to see the whole request. Here's the request. The source headers is the request. Okay. This is a real HTTP request, a post, and so on. So the previous one should have shown me that in the source headers. Okay, that's it. I was just having trouble seeing it. And I see this. This looks like an event forwarded from the server back to itself. So that event is not giving me what I want. Let me just try the next one. And you'll see here's a request. And this is from Mozilla. So this is a request. This is what I wanted to show you. This is a web request. It went to my server, it did a post, and here's the name of the server. But the point is, it has these fields. This is the Accunetrics vulnerability scanner. What these hackers did was they had a hacked version of a professional vuln scanner, and they ran it against the server. This is the sign of pretty stupid attackers. I mean, when you buy a commercial vulnerability scanner, it tags every request with an extra header because your security staff needs to know that's not a real attack, that's us scanning it. But if you're an attacker, you would have taken that out if you know anything. But these guys are idiots, and they just left it in there. So now we know two things. We know the name of the scanner they used, and we know who's attacking us. We know what IP they came from. This packet must have come from them going to our server. So the source of this...
Sorry, can you show exactly what those portions are? Where I don't see the IP.
No, you won't see it here. It's going to be in another field. This is the HTTP request.
So this is just a summary of the request, the details of what actually was requested, where it came through, we have to delve into deeper.
Yeah, because it's a log. That's the problem. It puts different fields in different places. So this is the request, and now I get the name of the scanner. Here's the source IP should be here. There's the source IP starting with 40. And by the way, this is where I start taking notes. Some of these we're going to need later. So the source IP of scanner. So this is one of the IP addresses of our attackers, is this number 40 and so on. Now, they were attacking my web server, so IP of web server. I got that too. That's going to be the destination IP of these packets. So that'll be up here where the D, there it is, 192 something. So now I know a whole bunch of things from here. I found the IP address of the attacker, I found the name of the scanner, and I found the IP address of my web server. And those
where they're coming from and where they're trying to get in.
Yeah. And I did it by spotting a malicious packet. And therefore, I know it's coming from the attacker to me. So I know, so now that answers the first several flags. The scanner name, the attacker IP, and the web server IP are the first three flags. So this is one way to use Splunk. But the next part shows you off how great Splunk is. Now, let's talk about network hygiene. Your web server should only be a server. It should be getting requests from customers and serving up a page. Your web server should never be a client. Nobody should be opening a browser on your web server and going to pages and download things. There are two reasons for that. The first thing is they might get it infected. If you want to put a file on the server, you don't download it in a browser on the server. You download it somewhere else, scan it for viruses, and then move it over with a file share or something. The other reason, which is more important, is if you take the pen testing class, you'll see everybody uses reverse shells. This is because the default Windows firewall blocks all unexpected incoming traffic. So if you want to take over a server, what you have to do is execute code on the server that makes an outgoing connection, saying, please control me, because all outgoing traffic is allowed. Incoming traffic is filtered. So if you were to start a listening process on a server, listening on a port, you wouldn't be able to connect to it. The firewall wouldn't let you in. So you make what's called a reverse shell. The server makes an outgoing request to the command and control server saying, please control me, and then you control it. And therefore, you don't let your server ever make any requests anywhere. Proper hygiene prevents your server from being a server. It's not allowed to be the source of any network requests. That should be blocked by your firewall and your routers and your traffic control. If your company is stupid, they fail to block that, and so we will find some packets going backwards through the network. And that's what we're going to find. So now that we know this, we're going to find traffic that went backwards through the network. So what we have here is HTTP going to the Batman server. Now I would like to filter by the client IP. So if I go up here and look at, say, client IP, I'll just click on any of these, because all I'm trying to do is get it to build this correctly. So now I can specify the IP address, and I want to see if there was ever a packet that came from the web server. So I take the web server address, and I put that in here for the client IP.
So you're basically saying, use my server IP to see if it's made any client requests.
Right, and that should not be allowed on a proper network. So I search, and I find 0. Now, let me just check and see if there's comments in the Twitch. Speaking of competition, we have one space left. Okay, that's good. Yeah, you can read that. Embedded security is looking for more people, so you can join that if you want. Anyway, let's carry on here. So now I found 0, but the problem is I left this I'm really not Batman in here. Now that's the name of this server. The outgoing address from the server would be going to somewhere else, like Google or Yahoo or something. So I got to take that out. An outgoing request wouldn't have that.
Because this is the hacker server that is receiving this client.
Right,
delivery.
it's some other server.
It's not the customer.
Right, it's
server.
not my own server.
Yeah.
My server didn't make a request to itself. It made a request to something else. So I need to remove that.
And now you put in the IP address from the hacker that you found, the fourth.
Well,
one?
I could, but I don't know that they would go back to the same
back to
server that
where
the
they-
scanner came
where
from.
they
So
originated.
right now I'm looking for any traffic that went backwards. And there were a total of 9 events that went backwards. This should never happen. If this happens, so I had 1 million events, and with just a few steps, I found the 9 suspicious events out of those 1 million events. This is why you pay for Splunk. This is quite an accomplishment. I found a needle in a haystack. I found the 9 suspicious events out of 1 million, and it wasn't that hard to do. And if that's why people pay for it. So these events are really suspicious. So all this garbage is downloading a binary file of some kind. And if I keep going down, I'll get the name of that file. That's what all that Unicode garbage is. That's the record of a binary file being downloaded. And here's the request that did it. And if I look through this, I'm going to see, here's where it went. It went to prankglassine.jumpingcrab.com:1337. So this is a goofy looking domain name on an unusual port, not port 80, not port 443, but 1337, which is a common hacker port. So this is a malicious server hosting content that they're downloading, and the name of the file they downloaded is here, get Poison Ivy is coming for you, Batman.jpg. So,
Sorry, Sam, I have
yeah.
a couple questions. One,
Yeah.
how do you know that port number is unusual?
because if you take Net Plus, you'll learn your common port numbers. And the common for web servers, HTTP is 80 and HTTPS is 443.
Okay.
And using anything else is very uncommon because then you'd have to type the number in the URL, and nobody wants to do that. So only hackers do that, or people who are putting up like a test site. Your customers will never put
Right, of course.
1337.
I never
So
used that
yeah,
for URL. So that is just basically designating a specific entry into the server.
right.
And if it's unusual like that, you're basically
That's suspicious.
narrowing.
Yeah.
You're basically saying, this is only an entry to this building that we know.
Right, and
That
so that's
I know and that you know.
yeah, and so that's suspicious. That is not something a normal server would do. And 1337 is leet speak. Leet speak is where you use letters instead of numbers. It spells LEET. That's the idea. And so that's a common joke, is leet speak. 1337 is a number a lot of hackers use. It's a common joke they have. So 31337 also. If you know hacker culture, there are certain ports typically used
There
for this
wasn't
kind of
so
thing.
much nudge, nudge, wink, wink.
Yeah, yeah.
So then if you were to take that URL and post
Yeah.
it into a browser, what would it take you to?
That's a very interesting question. We're going to get there. All right. So now we've got a bunch more flags. Now we've found the name of the malicious server and the name of the file. So what they did was they did a cheap punk trick. They downloaded a malicious file and defaced their web server. This is what punks do just to irritate you. Professionals will not do it because it doesn't accomplish anything, but it is a way to just annoy people. Put an unauthorized image on the web page. So now if you go back here, there's a few more flags. We found the file name and we found the domain name. And now, what you asked is very interesting, and I'll go on there. So now we also found the IP. So now we found the IP of the server that file came from. That'll be the place this request went to. So if I go back up here and expand it this way, I should be able to find the destination IP of that request. Because remember, the source IP is, of course, my web server. That's how I found
Right.
it. So the destination...
The 2322.
Yeah, here's the destination. So now I have another thing. This is the staging server. So here's more facts. The staging server.
And can you clarify what is the staging server? What is that?
It's a place where you host malware so you can download it. And they hosted a malicious image on there. And the name of the file that came down, I had up here, was this. This is the file name.
So a staging server is like a deployment location that you can access from anywhere.
Exactly. Yep. And so notice they had a different server for doing the scanning than they used for a staging server. Criminals use different servers for different purposes, just like the good guys do. They could, in principle, do everything from one server, but that's not what they did.
Well, because if that one gets shut down, they can't continue to operate.
Yeah, and they may have other limitations. So they ran the scanning from 40, and then they downloaded the malicious image from 23. And the other thing that's interesting is the malicious domain name, which was this. Okay, and now, what you asked is a very interesting question. What is really at that server? And the way you do it is to find out what else they've been doing, you can Google this domain name. Now, this is not working so well as it used to because this stuff is getting kind of old.
I think you just did a paste instead of a copy.
Did I? Okay, you're right. Thank you. I'll do back. Good. Okay. So if I Google that domain, that IP address, I'll find out what people have been saying about that IP address. And I'm looking for threat miner might be good. Robtex might be good. There are open source intelligence companies that record information about hackers and attackers. Now these guys know it's part of Boss of the SOC. That's not what I want. But here they show you where it is. It is an Amazon server. And I might be able to find the historical DNS, but it's taking time to load. Let's see if any of these other guys are going to load quickly. That's rude. Robtex is down. That's really rude. Okay. Let's see if I can find, that's NS Tools. Oh, that's Elizabeth. Let me see if I can find out what's going on with her. Okay. Hello? Yeah,
Hey, Sam.
yeah.
Are you still on campus?
Yeah, I'm on the same floor you are at the other end. I'm teaching a class in room 230.
Oh, okay, sorry.
Are you guys? Yeah, you guys all done?
Yeah, do I need to lock this room or anything?
Yeah, just close the doors, and you come down. Yeah, come down and meet me in 230 if you like. Okay.
2:30? All right.
Yeah, just at the other end of the hall. Okay, great. Okay, bye-bye. Anyway, all right, I just want to see if I can find any good stuff about this domain. I'm afraid I might not be able to anymore. It used to be pretty easy. Now it's gotten so old. Here we are, Sum of Apt Group. This one looks pretty good. Okay, Sum of Apt Group, Poison Ivy. Here's people writing it up. Yep, okay, anyway, that's the flag here is to find the other name of this group. And this is it, Poison Ivy spelled like that. And it used to be that you could find them in lists of malicious IPs, but because this data has gotten so old, it's hard to find. Anyway, that's all I wanted to show you today. That gets you the first few flags here. And you can see what you're doing here. That was 2.1 and 2.2. You have the staging server IP you can find. The LeetSpeak domain you used to be able to find by Googling that IP address, but it's kind of gotten old. Now what you'll find is write-ups explaining how to do these challenges, which have the answer, but that's not as much fun. Anyway, if you get hacked by somebody, like you open up one of these SSH servers and people start guessing, you can get their IP address and you can Google it and you'll see what other attacks that IP address has been performing. Because bad guys get a server and they use it for a whole bunch of attacks. And they put a domain name on it and then that gets blocked, so then they put another domain name on it. So historical records are often quite useful to figure out who's attacking you and what else they've done. All right. Anyway, that's all I wanted to show you. Let me stop this recording.